going to change gears a little bit today, and I think you guys are getting comfortable with identities, so it's probably time to try something new. So we are going to solve trig equations. Just as it says, you have to have your unit circle out. Your unit circle is going to be very, very helpful today. And you have two of them, there's a green one, and you have the one on that identity sheet too. So we're solving for x. So what I want you to do is think about this like it's a linear equation. So for example, let's say the sine of x was not the sine of x. Let's say it was 2x minus 1 equals 0. What would you do to solve for x? Add 1, and then you would divide by 2. So we have 2x equals 1, then we divide both sides by 2, which means then that x is equal to 1/2. We're going to do the same kind of thing today. But of course, it's a little bit more complex because it isn't an x, it's the sine of x. So what's my first step in solving for x? Add 1. So I'm going to do that. So I have 2 times the sine of x is equal to 1. And the next thing I do is divide by 2. So I divide this side by 2, they cancel out. I divide this side by 2, leaving me with the sine of x is equal to 1/2. The sine of x is 1/2. So what is x? So that's where you need to look at your circles, and you need to find wherever you have a sine value that's 1/2.
30 degrees.
Where is it?
30 degrees.
30 degrees. I want all of your answers in radians.
Pi over 6.
So x is equal to pi over 6. Is that one of your answers? You guys agree with that? A positive 1/2.
5 pi over 6.
Okay, so we have one of our answers is pi over 6. Because at pi over 6, our sine value is 1/2. Where else?
5 pi over x.
5 pi over 6.
I mean,
I knew what you meant. That's fine. So 5 pi over 6. And is that it?
yeah.
Why are we not looking at quadrants 3 and 4?
Because
They're negative. Very good. So that's it. That's how you do it.
I like that.
Now, this is an easy one. And you know what? They're not that horrible. So let's not start thinking negatively already. Well, for some of us it might be horrible. All right. Let's say I'm going to compare this to, for example, x plus, instead of using the square root of 2, I'm just going to use 2. X plus 2 is equal to negative x. The first thing that you would do in a problem like this is get the x's together. So you would take this x and you would move it over to the other side, leaving you then with 2x plus 2 is equal to 0. Would you agree? So we're going to head in that direction and see where this takes us. So the first thing I want to do is take this negative sine of x, and I want to move it to the other side. So I'm going to add it to both sides. So I have a sine of x and a sine of x. How many sines of x is that? That's 2 of them. So we have 2 sine of x is equal to, not equal to, I'm ahead of myself a little bit here, plus the square root of 2 is equal to 0. So, going back to this, what would be my next step?
Minus 2.
Minus 2. Minus 2, minus 2, so I have 2x is equal to negative 2. Correct? What am I going to do here? I'm going to minus the square root of 2. So I have 2 sine of x is equal to, these have canceled out. 0 minus the square root of 2 is the negative square root of 2. Now what do? You divide by 2, leaving you then, of course, with x is equal to negative 1 over here. But over here, we're going to divide by 2. So the sine of x is equal to the negative square root of 2 over 2. So what is x? Go to your unit circles, and you find anywhere that has a sine value that is a negative square root of 2 over 2. 5 pi over 4. Sounds familiar.
No. What is
5 pi over 4, and then there should be one other answer. Okay, wait. No, never mind, you're fine. Go ahead. What else? 7 pi over 4. So far, so good? I am going to compare this to 3x squared minus 1 is equal to 0. What do you do first? Add 1. So So 3x squared is equal to 1. And then, of course, the next thing you would do is divide by 3. So x squared is equal to 1/3. What's the next thing I do? Square root. And this is the thing you've got to be careful with. When you take the square root of this, x is equal to what? Yeah, but we have to remember that when you take the square root, you always get two answers. You get a positive answer and a negative answer. So this is the same thing as positive and negative square root of 1/3. And then in this case, the square root of 1 is 1. The square root of 3 gives us an awful answer. So this would be positive and negative 1 over the square root of 3. So for what that means here is, let's say you had x squared equals 25. You would take the square root of each side. X would be equal to what and what? Positive and negative. You usually include both possible answers. We're going to do the same thing with these. So, in comparison, while we're going to compare this to this, what is the first thing I'm going to do? Add 1. So we have 3 tan squared of x is equal to 1. Then you have to divide by 3. So we have tangent squared of x is equal to 1/3. It says tangent squared. We don't want tangent squared. We want tan. So I'm going to square root each side. So the tan of x, the tangent of x is equal to, first of all, how many answers are we going to have? We're going to have 2 of them. So we're going to have positive and negative square root of 1/3. But I got to clean that up a little bit. We talked about what it was actually going to be over here. So, positive and negative square root of 1/3 is going to be positive and negative. What is the square root of 1? 1. What is the square root of 3? Not a very nice answer, so we leave it like that. Now, do we need to rationalize the denominator? Let's not think like that yet. I don't think we're going to need to do that. What does tan mean?
Bless you.
It means
Opposite over adjacent.
opposite over adjacent. It also means sine over cosine. So what I'm really looking for is, where is my sine value divided by my cosine value, positive or negative 1 over the square root of 3. So you need to look at your unit circles and decide, where do I have a sine value when divided by the cosine value? Am I going to get 1 over the square root of 3? So don't get too flustered yet. So look at your unit circle, and you are looking for places. We want the square root of 3 to be on the bottom. So watch what happens here. If I took a 1/2 and I divided that by the square root of 3 over 2, do you see how we're taking a fraction divided by a fraction?
Yes.
The denominators cancel out. What am I left with? 1 over the square root of 3, which is exactly what I wanted. So you need to go to your unit circles and look to see, what is this top number again?
Pi over 6.
This is sine. Would you agree? Sine is on top. What's on the bottom? Cosine. So you are looking for sine values that are 1/2 and cosine values that are the square root of 3 over 2.
30.
Now, we are looking for positives and negative. So every quadrant that you have a sine value that's 1/2 and a cosine value that's the square root of 3 over 2 is going to work for this problem.
I hate writing 11 pi.
I know, I agree. Yeah.
Things like 1,
1, 1, 1. What is it, you guys?
30.
Okay. Pi over 3. I've heard that.
2 pi over 6.
2 pi over 3. What else?
How'd you get pi?
Yeah, pi over 3.
It's pi over 6.
Okay, I'm just trusting your answers right now. I'm not really thinking about what you're saying. You should have, it should be pi over 6. Should be pi over 6. It should be 5 pi over 6. Should be 7 pi over 6. And 11 pi over 6. These are not correct. Sorry, guys.
We just
Help me out again. Pi over 6. What are the other ones?
5 pi over 6.
Thank you.
7 pi over 6. And 11 pi over 6.
11.
Thank you.
I know. I always thought that when I did that.
Even though they're negative.
Sorry, what's that third?
Even though they're negative, because remember when we took the square root, we had to consider all the positive tangents and the negative tangents. So everywhere that has a sine value and a cosine value of this and this, positive or negative does not matter. All right, let's try one more example on film, and then I'm going to turn the camera off. Yeah. Hard one? None of these are hard. I have no idea what you're talking about.
Nothing's hard yet.
All right. Secant of
Or like
x.
you're not done, you're finished.
Humans are mad. Secant of x minus 2 equals 0. What do you do? You add 2? So we're going to add 2. I'm going to add 2. The secant of x is equal to 2. Well, what does secant mean? It means 1 over the cosine. It's the reciprocal of cosine. So this is kind of awkward. Secant of x. We don't have secants listed on our unit circle. So what I'm going to do instead is look at this as the cosine of x instead. We know that the cosine is the reciprocal of secant, so what is the reciprocal of 2?
1 over 2.
Remember, 2 is 2 over 1, so we're looking for cosine values that are a half. So you look on your circles, anywhere that has a cosine value that is 1/2 is what we're looking for. By the way, positive 1/2. So we're not looking at negatives this time. What do you
Pi
get?
over 3.
Pi over 3 is one of them. Very nice. And where else? 5 pi over 3? Okay. All right. Yes? Is that not so bad?
Oh, so hard.
Wait,
Yeah, I'm listening.
because I forgot to tell you to give us some homework with some crazy stuff on there. So, okay, how about you do one where it's like